Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics, and today we will start with the unit 3 and that too the structure of descriptive econometrics. In fact, we have already gone through first two units. So, in the first unit we have discussed details about the requirements of engineering econometrics, and then in the second unit we have discussed something the use of Excel spreadsheet for the data means the for the requirement of data analysis and the engineering econometrics. The thing is that here engineering econometrics basically it is the application of regression modeling, but one of the basic requirements of the engineering econometrics or something called as econometric modeling is to know about the descriptive statistics, and that is how we call is called as descriptive econometrics, and that too as per the requirement of advanced econometrics problem. So, what is all about descriptive econometrics? In this case we start with the basic statistics, and then we connect with the association statistics, and then we like to connect with the inferential statistics, the requirements like probability, sampling, probability distribution, sampling distributions, and these are the essentials, and these are the basics through which the actual econometric modeling can be applied or can be used as per the requirement of any engineering problems. So, now in order to know in details, so we like to know what is all about the descriptive econometrics and what are the kind of requirements to solve the engineering econometrics problems. So, in the descriptive econometrics, so we start with basic these are the basic coverage. So, measures of locations, measures of dispersions, then in the third part we will discuss measures of shape, and then finally measures of associations. So, these are the basic requirements of hardcore econometric modeling, and this is in this unit these four are one part of the story, and in addition to that we will connect with the probability distribution and sampling distributions, and in between we like to know how probability distribution, sampling distributions, and all these descriptive statistics are very useful or very essential as per the requirement of engineering econometrics. So, engineering econometrics basically starts with the simple modeling, that too with the help of a regression technique. But before we start the regression modeling, so we should have all these requirements in hand. Until unless you know all these items, you are not in a position to understand the regression modeling, and you are not in a position to do the regression modeling as per the requirement of any engineering problem. And in this particular lectures, so we briefly go through all these basic statistics, which we call as basic econometrics or descriptive econometrics as per the need of advanced engineering econometrics. So, now what is all about measures of location? In fact, we have already discussed all these details a little bit in the second unit while using Excel spreadsheet. In the Excel spreadsheet, all these statistics are there by default. Means once you enter the data, by default if you give any indications, descriptive statistic will appear automatically, and that will give you some kind of basic inference as per the data availability or as per the requirement of the any engineering problems. So, in the descriptive statistic, measures of location basically gives the signal that what is the average of that particular series, or what is the maximum minimum, which we have already highlighted, but still we are putting in a kind of structural framework, so that you can get to know details about this descriptive structure and that itself will give you some kind of better understanding and better confidence in fact while building doing or building advanced econometric modeling. So, basically in the measures of locations we will deal with three items, mean, median and mode. So, mean is the average of the series, median is the middlemost we have to find out medians, and in order to know that whether the particular series means say normally distributed or very well spread, what we can say, and there is a kind of skewed distributions or something like that, because until unless knowing the details, so you are not in a position to go for better modeling. So, that is why we in the first instance we have to report mean, median and mode, and then so these are all various mathematical formulas behind this measures of location. So, which in fact actually somehow essential, but they are not so a mandatory kind of requirement, because ultimately as per engineering econometrics problem is concerned. So, we are looking for something in depth search or something complex kind of findings. So, these are the basic statistics which can help something to understand the data and to help the advanced modeling, but this statistic by default will not give you better inference until unless you use advanced econometrics problem, but these are all mandatory or essential requirement for advanced econometric modeling. So, we are not going in details about the calculation. So, we can just simply convince that these are the items available under descriptive statistics or descriptive econometrics while solving any kind of engineering problems by the help of engineering econometrics. So, you are bound to touch upon all these basic statistics or descriptive statistics or descriptive econometry. So, that it will give you some kind of better understanding or better consistency to work out this particular problem. So, this is the median kind of structure. So, whether it is again well spread or not, and again so whether it is equally divided into two groups. So, it depends upon size of the samples, and the size of the samples may be odd in nature or even in nature. So, there is a structure how to calculate the median of the series, but in most of the instances we like to see whether the particular data is normally distributed and not normally distributed. So, that means most of the instances if your data is normally distributed, then most of the statistics are easily apply, and that will be very easy to understand and easy to apply and easy to get some kind of inference. But if the data is not well spread and not what we call as normally distributed, then that may lead to some of the other distributions. In that case, so the kind of investigation process, the modeling process, it is not so easy. It requires different kind of structural framework through which you can actually reorient the kind of modeling, and then we look for the kind of inference which can give you some kind of better results, right. So, similarly median in a kind of simple series or kind of group series. So, you have to be acquainted how to calculate all these things. Again, these are all basics, and you need not require to calculate manually. You just go to Excel spreadsheet and enter the data, give the command. So, automatically you will get to know. So, ultimately what is the minimum requirement, that you understand what are the basic econometrics or descriptive econometrics, and what are these indicators like mean, median and mode. So, what should be the kind of results, possible results, and depending upon the particular result, how is the kind of interpretations, and what kind of conclusions or what kind of inference it will give you. So, that you can better way you can actually analyze the problems as per the particular requirement. So, likewise there are different mechanisms through which you can calculate median. So, then the kind of structure is called as mode. So, what I am saying that in the measures of location there are typical 3 items: mean, median and mode. So, again connect as per the data analysis requirement, we are supposed to check whether the data is normally distributed and not normally distributed. So, now by using mean, median and mode, so you can get to know whether the data is well spread or normally distributed or not normally distributed. In one instance, you just report the mean, median and mode, and then you see whether mean, median, mode are coincide. If the mean, median, mode are coincide, so that means they are equal. So, then by default it is called as symmetrical distributions, and somehow it is normally distributed. When the mean, median, mode are not same, then that itself will give you indication that the distribution is not well spread or well distributed. So, then either it will be skewed towards right or skewed towards left. In that context, you have to be reorient the structure, reorient the models, then you go for the kind of analysis. Sometimes there is a kind of problem called as outliers. If there is a outlier in the data, so then that distributions may not be actually symmetrical. So, it cannot be there is a possibility that there is a means not normally distributed. So, because of this presence of outlier, if it is in the right side, then it will take you to the right skewed. If it is in the left side, it will take you to the left skewed. So, then accordingly, so it will affect the normality. So, if possible, so the outliers can be removed in the process of data analysis, and then you can go for the kind of investigation. Sometimes the situation like time series data, so here it is not so easy to drop the outliers and go go for the kind of advanced analysis, but in the in this context what we can do, we have to normalize the data, restructure the data, then try to minimize the kind of impact of outliers. So, we have a different procedure through which you can normalize the data, and then from the help of descriptive econometrics, you can get to know what is the actual scenario and how is the kind of shape of the distribution, and again after the transformation how is the shape of the distributions. Then there are different labeling through which you can structure the data, check the report the descriptive econometrics and check the kind of the pattern of the distribution or symmetry, I mean symmetrical structure, and then you will go for the kind of analysis. So, until unless you get the kind of proper structures, you should not proceed for advanced modeling. But there are n number of ways you can actually reorient the data to have the normality, but that yes, of course sometimes doing normality the original features you may lose. So, for that you have to change the modeling framework, and you may not normalize, but you can use the actual data, but in that context the functionality structures will change or modeling structure will change. So, then that will adjust automatically. So, so the problem of complexity or the kind of inconsistency will not arise. So, another kind of items in the this descriptive econometrics is that measures of dispersions. So, it will give you the indication that whether the data is well spread or it has some kind of skewed distributions or kind of right skewed or left skewed something. So, it depends upon the the kind of weightage of a particular indicator. So, in the measures of dispersions we have a different levels of statistics. So, like range, variance, mean absolute deviations, absolute average deviation, interquartile range, but ultimately one of the basic or standard statistic in this case is the variance and standard deviations. So, what I have pointed out in the last lectures that in unit 2. So, in a particular series, if the variance factors or standard deviation factor is coming 0. So, standard deviation is something square root of variance. So, squaring standard deviation again you will get variance. So, having the data whatever may be the size, just you in the go to the Excel sheet and ask for the reporting of variance or standard deviation, and you check what is the value of the standard deviation and value value of the variance. So, if it is means there are two instances in the first first hand structure. So, in the first instance, so either standard deviation equal to 0 or standard deviation not equal to 0. If the standard deviation equal to 0, then there is a high chance that you cannot go ahead with the kind of investigation for hardcore modeling, because standard deviation 0 means, so there is a high chance that there is no variations in the data. So, as a result you cannot go for predictions, it is already a perfect conditions. So, when there is a variations, that means standard deviation not equal to 0. So, that means there is a little bit uncertainty, and the job of the econometrics is to find out what are the factors which can affect the uncertainty. But when there is no uncertainty, so by default standard deviation equal to 0. So, in that case econometrics rule will be minimal, and there is a high chance that you should not use actually econometrics there. So, you will use econometrics when the data is unpredictable or a situation of uncertainty. So, we use econometrics modeling and a rigorous econometric modeling. So, to bring the uncertainty situation to certainty situation, so that we can easily predict the particular situation as per the particular engineering problems requirement. So, ultimately, so these are the test statistics which can give you some kind of better inference to go for the kind of modeling. So, range one of the indicators which is the difference between maximum and minimum, and the way we have already discussed in the last lecture, that in unit 2. So, here now we are using these two indicators and getting one particular indicator. That means, technically it is the difference between maximum of the series and minimum of the series. If the range is high, then by default there is a high chance that the data will not be symmetrical. If the range equal to 0, then that means data are uniform. So, if range equal to 0, then there is no need of again econometrics. If the range is high, then you have to understand and you have to actually orient the kind of data differently, so that the range should be less and less. So, what is actually requirement of econometrics is that, so your range should be low, it should not equal to 0, and it should not also very high. If it is very high, so the modeling structure may get affected. If it is 0, so there is no requirement at all, and if it is low, then it is good, but you have to go ahead with the kind of econometric modeling, so that the particular process can be apply as per the particular requirement. Similarly, there is a kind of variance factor which I have already highlighted. So, it is the square root of variance will get standard deviation, or squaring the standard deviation will get variance, but ultimately it will give you the kind of clarity that how spread is this particular distribution. Is it highly spread or it is very low spread? High spread means standard deviation will be very high, low spread means standard deviation will be very low, but not equal to 0. If it is equal to 0, game should not on. If it is not equal to 0, game should on, but try to have a low and lower variance. So, lower the variance, higher is the model accuracy. If higher the variance, then lower is the model accuracy. So, that is the beauty of the basic econometrics or descriptive econometrics, because it will give you a path or some kind of better understanding when you will go for in-depth kind of study. So, there are also various theorems which can talk about the details about the data patterns. So, that means ultimately whatever we have actually discussed till now, starting with the data understanding, the use of spreadsheet for again data understanding, again the use of descriptive econometrics or basic econometrics, again with the help of data and the techniques and the kind of spreadsheets and these kind of softwares. So, ultimately we are rigorously torturing the data one after another way. So, that will get better inference, and once you get better and better inference, then your modeling will be much better every times, and then it will give you some kind of better insights or new insights as per the requirement and as per your objective and goals of with respect to this particular engineering econometric subject. So, again there is a item called as a coefficient variation. So, it is the simply ratio between standard deviation to mean, and compared to variance and coefficient variation is a unitless measurement technique, and that will give you better kind of structure through which you can understand the data and get some kind of inference. And then again there is a kind of quartile, so which we have already discussed. So, that means the technical idea about the quartile is the entire data we can divide into different quartiles, and we try to see how is the median structures, again what is the average positions, and how is the kind of distributions. So, it is actually mean, and then with respect to plus minus standard deviation, 1 standard deviation, 2 standard deviation, 3 standard deviation. So, there is a theorem kind of structure that the range of the data should be within a particular labeling. So, means so we get to know how is the kind of shape of the distributions. So, we are looking for actually normal distribution, that is called as bell shape, but the reality is something different, because it is not in our control actually. So, we are just plotting the actual data and checking the reality or the shape of the distribution. If it is actually coming as per your requirement, that is fine. If not, then you have to actually manipulate the data or transfer the data in such a way that somehow it can be coming as per your requirement. So, that means in the first hand you try for that. If not, then you have to do the modeling as per the requirement only. That means, technically if the data is behaving like this, then you have to develop the model accordingly. For instance, if the data structure is structure is completely nonlinear, so you should apply some kind of nonlinear modeling. If the data structure is coming actually in a kind of linear structure, then you can also apply some kind of linear modeling. For instance, if you talk about regression modeling, so regression modeling can have actually linear structure, can have a nonlinear structure. So, now you cannot just blindly apply the linear regression modeling or nonlinear regression modeling. It is actually it automatically the data itself give you the indication that yes, this is the requirement of linear modeling or something called as nonlinear modeling. So, that is how. So, descriptive knowing descriptive econometrics very essential, and this will give you better kind of understanding. It is over and above than the understanding of the data with data visualization, data analysis, which we have already done through the use of Excel spreadsheet and the kind of basic statistic and basic functionality like mathematical function and statistical functions and something like that. So, now against there is a outlier issue which I have already mentioned. So, if there is a outlier, then it can affect the distribution heavily. Outlier, in the simple language, outlier means it is a data point which is exclusively highly distanced from other data points. And once it is highly distanced from other data point, and you are putting the boundary, because you need a boundary to report the mean of the series or median of the series or mode of the series, dispersion of the series. So, so mean, median, mode, dispersion, standard deviation, coefficient of variations, or whatever may be the kind of statistical indicators. So, until unless you know the lower part and upper part, that means the entire range of the data. So, you are not in a position to report the mean, variance or something like that. So, you have to know what is the total sampling. So, A to Z. So that which one, if you arrange the data in ascending to descending, which one is the lower one, which one is the higher one. So, that means once you enter the data, then with the help of Excel spreadsheet, you can actually completely reorient and restructure. So, every details will be there in front of you. Then you may be in a position to decide what is the next step and how is the kind of basic inference for this particular engineering problems or the kind of engineering econometrics issue. So, outlier is a very typical issue which can affect the system very heavily. So, try to avoid outlier in the data set, and in fact, it is very easy to avoid when the data structure is actually cross sectional type, and if the data structure is a time series, it is not so easy to remove the outlier, means you cannot just draw, but in that context you need heavy restructuring, heavy transformation, means you need to have solid transformation mechanism, so that the outlier can be actually means the impact of outlier can be minimized. Actually the issue is that so outlier is actually the structure of the data like this, and one data point is very highly distance. So, now one way of minimizing the distance is to normalize the data. So, for instance, the actual data, and then one way of normalization is the log transformation or exponential transformation. So, now you just have the data, actual data, and check the difference. Now, after the normalization and do the same visualization and plotting, you will find the group of data and the kind of an outlier, the difference will be slightly actually lower. And if the difference will be slightly lower, then that itself will converge to somehow normally distributed or symmetrical distribution. So, it is the requirement actually better processing of data will give you better kind of modeling results. If your data is not so good and the data is not so proper, so the modeling structure will get affected heavily. So, as a result, you must be very careful how you have to adjust the systems, and for that you should know the use of software, the basic understanding of the data, basic statistics or descriptive econometrics. So, that in a particular position you should actually adjust in such a way, so that all kind of obstacles can be minimized, and ultimately you will get some kind of better results and better insights as per the requirement of a particular engineering problem. Until unless you understand the data, until unless you get the inference, until unless you visualize properly, you may not be in a position to torture the data further to get some kind of new insights. So, you have to develop all kinds of means all these necessary, then you may be in a position to get some kind of new insight as per the particular requirement. So, another part of the structure is called as measures of shape, and here we have to go through a component called as skewness, and here even if the distribution is bell shaped, but still it can give you the kind of range whether it is actually very perfectly symmetrical or somehow little bit biasness will be there. So, it depends upon skewness statistics, and there is another statistic which can be connected to skewness is called as kurtosis, and this kurtosis will also give some kind of flatness of the distributions, and then that means technically with the help of skewness and kurtosis. So, we can actually differentiate the particular structure and to know the know the structure of the data and as per the particular modeling requirement. So, at a particular point of time your measures of location, measures of distributions and measures of shape must be available to understand the data very perfectly, and it will give you the kind of shape and structure, so that the proper modeling can be applied, can be used as per the particular engineering requirement. In fact, reporting this is how the kind of shape of the distribution. So, it should be a completely bell shaped, it should not be a very flat or a very pegged kind of situations, but it should be what we call as normally distributed. So, that means technically, so the green here the green one is a kind of top class, and then if not, then you will find somehow different shapes altogether, how best it is actually equally distributed. Yes, all are looking normally distributed, but out of this which one is the best, that itself will give you some kind of beauty to these systems and against the requirement of engineering econometrics. So, likewise what I can mention that in this particular lectures. So, we specifically highlight the descriptive econometrics, that to basic econometrics, and with a special reference to measures of locations, measures of dispersions and measures of skewness, that is actually shape of the distribution, means measures of shape, or you can say. And that means technically all these three items will give you some kind of better understanding of the data, in addition to the visualization process, or in addition to some of the basic understanding of the data. So, this will give you, means this is a second stage of the process. In the first stage, you have to understand the data by look and by some kind of visualization techniques like graphs, charts, diagrams, etc. Then against you are torturing the data and try to understand the pattern of the data with the help of some of the basic econometrics or descriptive econometrics. Ultimately, you are supposed to know what is the kind of structure through which you can actually analyze the engineering economics problems in a much better way. Okay, so means what I can say that these are all essential. Ultimately, you are not supposed to actually calculate anything. So, the software itself will give you all these values, or Excel spreadsheet by default will give you all kinds of values. Ultimately, it is you to understand and get some kind of inference and choose the models as per the particular requirement of the engineering problem and as per the requirement of the data. So, that means, so engineering problems requirement and the kind of data structure. So, it should be go side by side. So, if the you have to, ultimately your objective is how to actually analyze the engineering problem, but in the same times you should not actually ignore the data data obstacles. So, with respect to the data, whatever the information is there with again with respect to engineering problem. So, it should be actually integrated properly, so that your inference will be much better. If you actually just give focus on your objective and not focusing the data structure, then it may be a kind of biased result. So, that is why you have to keep stress on both data structure and the kind of problem requirement. So, then you adjust accordingly. I am very sure you will get some kind of path through which you can analyze the problem in a much better way. So, with this actually we will stop here, and basic suggestion is that you have to be acquainted with the descriptive econometrics in order to understand the data, and in order to analyze the engineering problem in a much better way. In the next lectures, we will discuss something more about this in descriptive econometrics. Thank you very much. Have a nice day.